Okay, thank you everyone for joining us. Looks like people are kind of filing in here.
Recording in progress.
We do have a lot to cover today, so I do want to get started, and there'll be time for folks to kind of continue joining us as we get going. So my name is Steve Herman. I'm the engineering manager with Water Smart Solutions, and we're very pleased today to be partnering with the Clean Resource Innovation Network, or CRIN, to be putting on this webinar. And we're looking forward to helping cultivate some connections between folks within the water industry and talk about some cool technologies. Before we dive in, though, I do want to take this opportunity in the spirit of respect, reconciliation, and truth to acknowledge that we all live, work, and play on Indigenous traditional lands. As this is a virtual event, you know, we know that people are attending from locations across Canada. Myself, I'm in Calgary, so I'm on the traditional territories of the Blackfoot Confederacy, which includes the Siksika, the Kainai, and the Piikani, and the Treaty 7 nations comprised of the Tsuut'ina, the Stoney Nakoda, including the Wesley, the Chiniki, and the Bearspaw, and the Métis Nation, Métis Region number 3. And as well all other Indigenous people who make their homes in southern Alberta. And we at CRIN, we do encourage you to research what Indigenous traditional lands you are situated on, and think about making or finding your own land acknowledgement that you can use as well. So with that, let's dive in. So a couple housekeeping items, and then we'll get moving to our speakers. So please do stay on mute throughout the presentations. We structured this so that there is a breakout session at the end. So during that time, we encourage you to show your camera and get off mute and have a good conversation. But until then, please do stay on mute. And as well, the webinar will be recorded, so get a copy of the slides and the recording out to folks. In terms of questions, we ask that you do ask questions. You should be able to use the Q&A or the chat feature, and we'll monitor that. And if you can direct a question at a particular speaker, I'll try and go through and after each presentation ask one or two of each person, depending on the time. And if you do have other questions that are trickier or perhaps don't get answered, then that's the perfect time to come to that breakout that we talked about at the end of the session and ask those questions of the speakers directly. So do encourage you to stick around for that. We'll give a little bit more detail before we dive into what that entails as well. And a note, we do have quite a lot of content to get through, so I will be checking the time quite closely. So I apologize in advance if you see me popping in to kind of usher things along, but just trying to make sure everyone has a chance to speak, and then we have that time at the end for the breakouts. So here's the agenda for today. We do have 5 speakers presenting on various water technologies, which is pretty exciting. Before that, though, I want to pass things over to Adele Zenade from Canadian Natural. She's the co-lead for the CRIN Water theme. She'll do a brief intro to CRIN and CRIN Water, and then we'll dive into our presentations. So Adele, over to you.
Thank you, Steve. And hello all, and thank you so much for joining us today. For those of you who may not be as familiar with CRIN, it is a network of networks which aims to accelerate the development of groundbreaking solutions by establishing industry priorities and developing connections between innovators and resources. As you can see on this diagram, it's a very diverse and busy ecosystem, but everyone shares a common passion for innovation to ultimately help lead the way to a clean energy future to ensure Canada's long-term prosperity. CRIN is organized around 7 technology theme areas, 19 sectors, and we have a very healthy and growing 3,000 membership base. And we are hoping through all our events to create collisions, connections, and discussions. You can think of CRIN as an amplifier for networks that are already in this ecosystem. It is really the and in the Canadian conversation about energy that really seeks to change the narrative from choosing between one energy source or another to being about energy sources complementing each other. Within the CRIN theme areas. We come today to you from the Water Technology Development theme. And our goal has been to create connections between innovators, vendors, water specialists, end users, government, collaborators, and so on and so forth across Canada. And really our goal is to share common challenges and potential solutions and technologies to these. And we do this through various tools. As today you can see, we're hosting a webinar with various solution providers. We also have a wealth of online resources on our website, cleanresourceinnovation.com. And we've also posted the challenges from our water theme, which we've gathered across Canada in different industries. So today, without further ado, we'll be discussing one of our top challenges in the water treatment theme area, and that is related to online analyzers. We have solution providers presenting water quality and water cut technologies. And first up, I'd like to introduce Dr. Apostolos Kanzas. He's the president and CEO of PERM Inc., as well as a professor at the University of Calgary. Dr. Apostolos Kanzas.
Thank you very much. So welcome all. Good morning, good afternoon if somebody is not in our time zone. What I'm going to briefly discuss today is our magnetic resonance-based metering systems. In particular, what we measure is CAT. Next slide, please. Or can I drive myself? No. So the principle of the technology is that if you have a proton-bearing molecule and you put that in an oscillating magnetic field, what you're generating is you're generating a accumulation of energy in these hydrogen-bearing molecules, and when you stop exercising these oscillating magnetic fields, these hydrogen-bearing molecules will precess or try to go back to their original state, and by doing that, they are emitting a little signal which is in the radio frequency range. You actually take that signal with an antenna and pass it through an amplifier, and you generated a sequence of signals of decaying amplitude, and this is called the relaxation decay curve. You invert that and you get a relaxation distribution which looks like the graph on the right. And if this hydrogen-bearing molecule mixture is oil and water, the signal between oil and the signal between water will split, and the splitting distance is proportional to the viscosity of the fluid 1 versus fluid 2, in this case, proportional to the viscosity of oil. Next slide, please. Based on that, we developed a system which we have successfully tested in a few different locations in Alberta, particularly for thermal recovery systems. The one you see here is the green dots are the water cut calculations over a period of several months. The red dots are mass balance allocations based on a pilot. And what I have shown you there is two different relaxation curves. The one on the top is when we have a high water cut emulsion, and the one on the bottom is when we have a low water cut emulsion. And from the location of the peaks and the area under each peak, you can actually calculate the water cut and the oil cut of this sample. And if that doesn't match your total volume of your pipe, then the difference is gas. Next slide, please. We have also tried that in mining. And in mining, we have, because in mining, we have an additional variable, and this is the solids. We have combined that with the density meter, and we were able to provide to the company the water cut, oil cut, and solids cut for each one of the streams that they pushed through the system over a period, again, of several months. And then we also managed to get subsamples and pass it and do the DIN-STARC analysis. And you can see how the results compare to DIN-STARC. Next slides, please. In terms of application, because it takes, you would like to have the sample in the magnetic field as long as possible. What we built in all our testing to date was a slipstream where the fluid is passing through the magnetic field continuously, and then when we want to take the measurement, we divert the stream to the slipstream. The schematic is like this. This is a version of an earlier model that we had used in the field successfully, and we have done different modifications with the valves to cut cost of the installation beyond the system. Next slide, please. This is what our latest version of the instrument looks like. And this, in terms of dimensions, is about 1.5 meters in height and a little bit less in width and about 1 meter in thickness. The red thing that you see in there is the magnet system, and the CRIN is the pipe that goes through it. And all that is built with specialty materials. Next slide, please. So these are the specs for the magnetic field for the size of the sampling and the mode of acquisition. For those of you who are versed in magnetic resonance technology, the mode of acquisition is just a standard magnetic resonance acquisition package. Next slide, please. And this is the specs in terms of power, certification, and communication. We have tried, the maximum temperature design is 260 C. We have successfully tried it up to 220 C. There was no other higher temperature sample pass-through ever. And there is two options that we have. We have a shallower and a deeper type of formation that we have looked at. And so they come with their own APSA certification numbers. I think that's my last slide, if I remember correctly. Yes. If anybody's interested to talk to me about that, please feel free to contact me. Either in the special session afterwards or after the meeting through my email. Thank you very much.
Great, thank you very much. You've set a good pace so far. I don't see any questions in the chat, so just remind everyone again, if you do have a question that you want to ask, we do find it helpful to have kind of a group discussion for these, so feel free to throw that in the chat. I do have a question for you, though, kind of off script, but can you comment a little bit on kind of what's next? You mentioned a couple of deployments you've done in different sectors. Do you have a vision for where you'd like to take this technology in the future?
We have, before COVID hit and everything got paralyzed, we had designs of miniaturizing that to put it inline as opposed to online. And also we have looked at some specialty applications on sales oil as opposed to the emulsion that comes out on surface from the thermal operations. And so these are some possibilities moving forward, but the rest is get people to buy the instrument and install it. The major stumbling block was that the facilities design groups always have difficulties to adapting those into older pads, because older pads are supposed to have no expenses, and so this adds to the expense.
Okay, good stuff. Thanks for that.
You're welcome.
So let's move on now to our next speaker. I'd like to introduce David Lloyd, who's the CEO of Fredsense. David, over to you.
Thanks so much, Steve. Good morning, good afternoon, everyone. It's a pleasure to be here with you. Thanks so much for the opportunity to present and talk a little bit about Fredsense. My name is David Lloyd. I'm one of the co-founders here at Fredsense, and I'm the CEO. Next slide. Before chatting a bit about Fredsense, I did just want to talk about some of the challenges that we're currently facing within the water industry in general. We're seeing a number of factors that are creating stressors on water systems, whether they be from a utility system, a mining system, or infrastructure in general. And there's a number of new challenges where technology really will enable the industry to move forward more rapidly. Some of these are looking at some of the challenges in terms of increased regulation around what discharge can look like, or what drinking water systems are able to put into a distribution system. We're seeing a number of new types of emerging contaminants and compounds that we're finding more and more health data around, PFAS being one of them, for example, that we need to be able to treat and monitor and deal with in our systems. We're moving towards new technological practices like water reuse or highly distributed systems, and ultimately looking to decrease the cost and efficiency of our treatment to help the bottom line of organizations that are there. All of these challenges rely on the ability to quickly and accurately generate water quality information. And this really will allow us to advance many of the different areas in the water industry to be able to meet some of the growing demands that we have on these systems to perform better and stay in compliance. Next slide. But in order for us to be able to meet these requirements, there is a bit of a problem. Today, if you're an operator within a infrastructure system, pretty much anywhere, you have to choose between the trade-off of using the technologies that are available when it comes to water quality. For many, this means that you have the choice of being able to use the lab, where you can get highly accurate results. But oftentimes, particularly if you don't have a lab on site, there's a long period of delay to get this information, and it can be very expensive. And today, there's a number of different types of field kit systems and analyzers that are available that can produce a lot of this data rapidly, but oftentimes it doesn't have the same level of accuracy or data integrity that you can get from the lab, or they can be very complicated for an operator to be able to calibrate and use. So today's testing methods really are having trouble driving a lot of the accurate real-time insights that we require in order to meet this growing demand. Next slide. At Fredsense, we're thinking about these problems in a way that allows us to be able to bring lab quality-based water quality testing anywhere, bridging the gap between the accuracy that's needed within the lab and the portability and real-time data generation of these simple systems to be able to support utilities, environmental consultants, and industry have empowered decision-making at the operations level to understand what's going on within those operations and how to respond to changes. Next slide. At Fredsense, we think about these kinds of problems differently. One of the major challenges in the space today is that if you go to any utility or differentiated system, the types of water quality challenges that are made available are highly differentiated. So one mine may have a very different set of problems from another. They may be regulated in different ways. And what this means is that we need different types of water quality tools in order to be able to provide this information. At Fredsense, we're commercializing a platform technology that gives us the ability to analyze virtually any type of compound that you would need to understand within a system, all utilizing the same hardware platform, the same use case for water quality specialists to be able to create reliable, simple, and real-time insights. Next slide. What's powering this system is a brand new technology that's being implemented into the environmental space. Fredsense is a group of synthetic biologists and hardware engineers that believe biology is the way to answer these types of problems. We have over millions of years seen organisms evolve to be able to detect and respond to a variety of different types of compounds that are found within our environment. And what we do is we utilize that capability to create these different types of sensor systems that are integrated into our hardware. Our system is electrochemically based. So we take these organisms and we engineer them to be able to detect the compound you're interested in and produce electrochemical signals when they're there. So a way to think about it is almost as if you took a pH meter or an ISE and you just put an organism on top of it to convert the chemical signature you want to measure into one that's highly tuned for your probe. So this is an incredibly accurate system. It allows us to have very low sensitivity. And the electrochemical nature of the technology also means it's highly immune to matrix effects. So we can use this in a variety of different types of use cases. Next slide. So as a technology, we've been able to go and prove that we can use these kinds of organisms in order to generate these signals and produce electrochemical field kits that can empower communities to make quick decisions. The hardware platform has been shown to be able to be integrated with different types of sensors. We've launched one of these into the market here in North America for arsenic that I'll chat about in a bit. It's been able to generate some real-time insights. We can customize the technology for a variety of different types of compounds, from lead to PFAS to COVID-19 RNA analysis, and even look at things like selenium. So we have a number of different types of product opportunities, all that utilize the same hardware system. Next slide. We also have a very different type of business model. So we produce the hardware and the individual cartridges that are one-time use. So it's a razor blade type of traditional field kit system that would be available to utilities and consultants for driving their insights. But Fredsense behind the scenes is powered by relationships with some of the largest synthetic biology companies in the world, where we have exclusive agreements to be able to custom design using their genetic systems that are traditionally used in the life science and biotechnology space to produce these sensors on our platform. So this means that we have the ability to go out and custom design new types of sensors on the system based off of what our customers' unique needs are. Next slide. So we've been able to deploy this technology with a variety of different types of end users. We've worked with government agencies like the US Geological Survey, Government of Canada, and the EPA. We've worked with utilities and drinking water organizations like LADWP, City of Phoenix. We've even been able to deploy this and show value within the mining space in tailing systems for our different sensors. Next slide. I just wanted to talk really briefly about what one of these sensors looks like and what kind of impact it can make. Our first sensor that we've deployed now at over 15 different utility sites is for arsenic analysis. Arsenic is a naturally occurring compound that affects about 3,000 to 5,000 different water utilities within North America. Because it's naturally occurring and highly toxic, it's at very low levels. It's difficult to treat, and oftentimes process control is very important. We've undergone a large project with the City of Phoenix that has naturally occurring arsenic in their groundwater. They're a heavily reliant groundwater utility that has active treatment at over 13 of their groundwater wells throughout their infrastructure. And we're able to utilize the system to drive value in creating faster and more accurate detection of arsenic versus the lab. Next slide.
Okay, and David, this is your 2-minute warning.
Awesome. So just a quick point on the data, just so that you can get an idea of how it compares to what's traditional. This is just some examples of some information that we collected with the City of Phoenix to show that we were able to hit the same level of information as what was done with the regulatory requirements through the EPA method. And so this was a valuable tool for them to be able to drive these insights in the field without incurring those laboratory costs. Next slide. So Fredsense as a company has been able to show that we can productize this biotechnology. We can have it approved through regulatory agencies for deployments, and that we have a number of customers that are interested in the work we are doing. And now we're shifting to becoming much more of a platform, onboarding these new types of sensors. We're going to be launching a number of them in 2022, 2023. And we're looking for customers and partners that are interested in seeing how we can utilize this hardware in new and interesting ways. And I think I'll stop there. Thank you so much for the opportunity, and I'm really looking forward to having the discussion in the breakout sessions.
Great, thank you, David. Yeah, really cool technology. Don't see any questions in the chat, so you're off the hook for now, but yeah, looking forward to those breakouts. So we'll flip to our next speaker. From 2S Water, we have Anthea joining us today, who's the CEO and co-founder. So over to you.
Thanks so much, Stephen. And you know, I just love going right after Fredsense because we have really complementary technologies. Fredsense is the perfect solution for when you're in the field and when you need to take spot sampling at various locations. 2S Water are the solution for when you actually need to do that same kind of monitoring inside a facility at a fixed location. Next slide. So we're really kind of addressing the same problem, which is stale data. Testing is intermittent. Right now, you're taking a sample and either mailing it to a lab or running it through your in-house laboratory. Next slide. The cost of human sample taking is more than just actually getting that sample, though. It takes a lot of labor hours. Remote locations can be difficult to access. COVID restrictions have only made this more difficult, getting people onto the site in order to grab those samples for analysis. And of course, any process that involves a human is error prone. Next slide. Once you've got the sample, then what? Now you're mailing it to a laboratory. Here in North America, that's 72 hours to 10 days wait. I do not recommend having a facility in South America because you could be waiting 2 months to get your test results, which is just unreasonable. When the data finally does arrive, you get it in an email. It's not integrated and it's not accessible in a way for operational decisions. So that's another problem with the current methodology. Next slide. The in-house lab is a good alternative to speed up that cycle. Then you might be getting your results in 4 to 8 hours at the cost of a few $1 million to set up, you know, a couple $100,000 a year to run. And still, with all this expense, you are now getting your data via email. It's still not integrated and it's still highly time delayed. Too delayed for, oh, I'm sorry, I've lost my video for a second.
Sorry, Anthea, I just turned off your video for a second to see if that would fix your sound. You've got a lot of static, you're really garbled.
Oh dear. Okay, give me 1 second. I'm just going to try and turn on and off my headphones. Can you hear me any better now?
Loud and clear. That's
awesome.
Perfect.
Okay, my apologies. Luckily, I always run short on time, so that should not be a problem. Thank you so much for pointing that out to me. So even when you have an in-house laboratory, you're getting your test results too delayed for in-process optimization, for environmental compliance, or for machinery maintenance. Next slide, please. 2S, so what are the results of this? It's damaged machinery through scaling, through corrosion. It's site shutdowns for non-compliance to your environmental standards. Those site shutdowns are often tied to expensive fines. And of course, anytime that you're getting metals in the output of your water treatment facility, that's lost revenue. Those metals are usually revenue generating and have now been flushed out. They've gone from an asset to a liability. That's the last thing that we want. And of course, the high cost of testing adds into all of this. It's a huge problem for multiple industries, both in oil and gas and mining, which is kind of our early clients. If you could switch to the next slide, please. The 2S Water sensor solution connects directly to a pipe and scans for up to 31 different metals, including heavy metals. We are real-time analysis, so we generate 1 data point every minute, and we're placed in situ, connected directly to the pipe. Next slide, please. Here you can see some examples of what our sensor looks like actually deployed into the site. We connect directly to where the problem is and scan on a continuous basis. It's a fully automated system, so no user intervention is required. Plug and play. Next slide, please. We connect directly to the sample source. The sensor handles sample taking, sample preparation, and then outputs the data into a format that the operator can use it. Next slide, please. So we are fully Scada integratable or control system, whichever control system that you use. We generate parts per billion resolution on different metals, and it's fully automated with IoT integrations. That means you can plug it into a site where you don't normally have an operator attending that site and get your data right back to your control system where you need it to make operational decisions going forward. Next slide, please. Whereas David's technology has taken biology to solve a chemistry problem, we've taken physics to solve a chemistry problem. So our core sensor can see 78 different metals. 31 of those we have validated in laboratory based upon current market needs. So in that list, you're going to see your major metals for human consumption. We validated on arsenic, on lead, on iron, thallium. We have our major metals for scaling and corrosion. So calcium, magnesium, lithium and copper are actually both major scaling agents as well. And our metals of concern for the mining industry, which is our primary target. So all of your extractable metals, gold, silver, copper, nickel, the primary ones that are of concern for those industries have been validated and tested in site, and many more are under development at this point. Next slide, please. So where do we use this? Well, we have three major applications where we see this technology bringing a lot of benefit. One is process optimization, then machinery maintenance, and effluent monitoring. Next slide, please. I like to start with process optimization because I think it's my favorite. It's where we can do the coolest kind of stuff. So the two first applications that we've looked at around in-process optimization are around the extraction of lithium from brines and around the optimization of processes where the process goes to a fully aqueous state. So often in mining, we find that that's leaching processes, such as the gold cyanide process, or mixed stream analysis, such as nickel cobalt analysis, for optimized extraction from stream. For the oil and gas industry, we've looked a lot at brine extraction from post-production non-conventional waters, where these are actually often very heavily laden with lithium brine, which can be extracted to provide a secondary source of revenue before the water's put back down whole. So some really interesting stuff we can do there. And we're always looking for partners to explore different in-process optimization applications. So if you have one that you think might this be applicable to, we'd love to talk to you about it. Next slide, please. Machinery maintenance is a bit more of a simple application, a much more well-known one. That's where we're looking for scaling agents on boiler water. So your calcium, magnesium going into that, so we can optimize that softening process before it goes into the boilers. As I'm sure everyone in the audience knows, even a minor scaling factor on some of the large industrial boilers that we see in oil and gas can be a huge, huge expense in terms of day-to-day fuel costs for these facilities. So very important to tweak that process. We can also help around closed loop maintenance and corrosion detection, where we're looking for trace amounts of these metals coming through in water to determine in a non-destructive and non-invasive manner when corrosion is happening upstream from the sensor. Next slide, please. And of course, effluent and tailings monitoring is probably our biggest application because it stretches across so many different industries. We monitor both the input and output of water treatment facilities. But output monitoring, we provide environmental compliance. We can let you know that the water is safe and clean to release into the environment, or if it needs to go back into process or potentially into tailings for long-term storage. That helps promote both environmental compliance, reduce fines, and increases social license to operate as communities downstream know that you're doing your absolute best to keep the water safe and clean. By adding input monitoring as well, we can then run water treatment system optimization and reduce chemical costs in your water treatment facility. By having that kind of real-time data, we expect to see a 25 to 30% reduction in chemical costs at a water treatment facility. So it's a significant savings by having that data in order to tune the process going forward. And we put it, as we said before, right there on the operator's SCADA system so they can make those operational decisions without having to reach that data somewhere else. Next slide. And of course, once you're sure that your water is cleaner and safer, you can increase recirculation. That's an important goal for any company, is to reduce that fresh water consumption and to use more of that water more times throughout the facility. By having that up-to-date and accurate information on the quality of water, we increase recirculation going forward. Next slide. So that's us, that's 2S Water. We are at this point in early pilot deployments. We are looking for more use cases for more innovators in the industry who want to help validate the product with us and make sure it fits to your circumstances, your water. So if this sounds like something that is of interest to you, or if there's a project that you think that we could be of help on, please reach out to me and come hop into our breakout room later. We would love to meet you. Great, thank you very much.
Great, thanks, Anthea. And like you said, it is cool to see the bio side with Fredsense and then the physics side here kind of complementary. There's a question, and I think it may have been for Fredsense, but it's an interesting one too, I think, for you guys. Do you have a temperature limit for your operations?
So for us, we do have a temperature limit of about 40 degrees Celsius right now. Color me frustrated because it's one part that we're trying to upgrade. Once we upgrade that part, we will reach about 90 degrees Celsius as our operational limit for incoming water temperatures.
Okay, awesome. Thank you very much. Okay, well, let's roll right along. Next up, we have Joe Schuler from Kentron Systems. He's the president there, and we'll be talking about an interesting oil and water technology. So, Joe, over to you. Oh, Joe, looks like you're on mute.
Looks like I've got to learn to unmute myself. I might be more interesting in mute, but we'll we'll let you guys determine that. So Kentron Systems, again, Calgary-based distributor of various analyzer and physical layer components. One of the challenges that we all face is in two different spheres. One is water cut, as we saw earlier, and we'll see next speaker talking about, and that's a 0 to 100% for production. The other end of this scale is on water treatment, is to get down and measure oil content in the ppm level, and that's been an enormous challenge, especially with the conventional method of measuring being TDL, tunable diode lasers, which have two limitations. One is to get a laser into a process, you must have a sapphire lens, which coats up very quickly. And secondly is a reliance on the aromatic hydrocarbons so that it can fluoresce. So we've been involved in that end for quite a long time. And then we, 2 or 3 years ago, started working with a Norwegian company called Miramurax, which is dedicated to oil droplets down to the 0 to 100 and ppm level and above. Next slide, please. So the application for the physical components is an inline retractable probe. We focus in on two different areas. One is water disposal and tailings applications, or just downhole water disposal. A couple of applications where people are putting 1,000 to 3,000 ppm of oil downhole. At 50,000 barrels a day, you're looking at least 50 to 100 barrels a day, which these oil prices are enormous revenue. You've produced the oil, now you're putting it down whole, and also causing well servicing applications. The second is, again, it's SAGD, because you have no groundwater to use. You have to recirculate the produced water that is generated from steam injection. So that's been a real challenge. And that's the application for this probe, is to be in process at high temperatures and being able to measure down to a range of 0 to 100 ppm, calibrated down to 0 to 1 or 0 to 10 ppm with good accuracy. And then combining that with the automatic cleaning system, which we'll talk about some of the benefits in a few slides coming up. Next slide, please. So this gives you a cross-sectional view of the probe in line. Again, a slipstream measurement you're not measuring what's in the process. You have all sorts of things that will reduce temperatures, precipitate out oils that may not be in a liquid form, and also a good robust titanium rod, so that you've got any kind of high chlorides and corrosion doesn't pose any problems. The ability to retract and inspect the probe, clean the probe manually if that's desired. With the automatic cleaning system, that's no longer a requirement. Next slide, please. So again, looking at the ability to measure not just the oil droplets in the water, we can also measure through the technology, and I'll explain that in a few slides, is we can also give you sand concentration as well as salinity measurement. The probe operates with entrained gases also, and then three ranges: 0 to 100 ppm, 0 to 2500 ppm, and 0 to 25,000 ppm, and then calibrated anywhere in those ranges with a 1% accuracy. So that we can get down to very finite measurements and unaffected by aromatic hydrocarbons and limited ability of measuring those kind of concentrations with a fluorescent type technology. Next slide, please. Again, so how does that accomplish it? So we've got a nice big measurement window, and it's an ultrasonic signal. So again, we don't care about, the technology doesn't care about oil densities, the oil changing properties. It recognizes the difference between oil droplets and sand particles, and it builds up a standing wave frequency, and it looks at the resonant and reflective ultrasonic signals coming back and the properties of the oil droplet. It absorbs the frequency, causing a much different signature, as well as sand particles. Also, they reflect the frequency. So doing 30,000 measurements and analyzing the particular characteristics of that molecule, you have a real-time output of oil, droplet concentration, sand concentration, and again, salinity measurement. You're looking at the speed of the sound going through the process. So with both temperature and the density measurement, you have the ability to output in real time both temperature and salinity, and a nice big measurement window that you're not going to be worried about pressure drops, as well as immediate plugging. Next slide, please. So again, we look at a completely self-contained system with the probe inline measuring, and then as you get into the higher concentrations, oil slugging and oil buildup happens with any probe that is put in situ. So one of the unique features of the probe and being able to clean the system is not using ultrasonics, indirect type of measurements, or mechanically pulling the probe out, which means you have a loss of available signal. And this needs to be, in process control, needs to be a real-time, 100% available measurement signal. So that uses, with a high pressure small accumulator and a pump, we're flushing out at high pressure, and you can use water, methanol, any kind of fluid that you have. Low concentrations, 0.1 liter per pulse, 3 pulses high speed through an accumulator, gives you very efficient cleaning. And rather than waiting till the thing is plugged up, we advocate that you do that typical cleaning frequency of 2 to 4 times a day. So, worst case, you're putting a liter of water back into the water, but this removes the ability to, or removes the need for maintenance, loss of signals, which has been characteristics of most of these ppm oil and water meters. They're either offline or laying on the floor in a shop out in the field. So available data, real-time data, and multiple components. Next slide, please.
Great. And Joe, this is your 2-minute warning.
Perfect. And this is just a schematic that is, of course, the text is too small, but that's something in the breakout room we can discuss how that flushing system works. Next slide, please. So people say, what does it look like when your probe or any glass lens starts to coat? So even anything up to about 50 ppm can continuously build up, which you'll see on the upper left photo, and the lower one is you get a tremendous amount of oil buildup, which isn't going to get removed by just vibrating an ultrasonic signal. You need to have something with physical properties, the mechanical means to remove the cleaning. And on the right-hand side, you see the Miramurax sensor coated with the oil, and then after a flushing with the cleaning system, because that is integral to the probe itself. So it is very effective, as well as keeps that measurement up 100% of the time. And we do it on a proactive basis as opposed to just a reactive basis. Next slide, please. Again, a little bit of a history on the company. So it has been around since 2010 in Norway, large overseas and offshore installation base. And again, the multi-phase sampling systems and inline water and oil analyzers, as well as topsides and subsea. And then we are the Canadian and Alaska representatives for Miramurax. And next slide. So we just have a quick summary. Ultrasonic measurement technology, which isn't prone to the limitations of some of the existing TDL technologies. Cleaning system developed up to 25,000 ppm, where most measurement systems in TDL are limited to 2,000 ppm maximum. Robust for change of mixed oils. It doesn't care what the oil properties are for both density and aromatic hydrocarbons. It's just that it is an oil droplet. Minimum maintenance, which is a key feature to keeping not just the cost of maintenance, but making sure you have 100% availability of your signal. Now that makes it a tool for process control. And then again, in Norway, we're doing a lot of regulatory reporting for offshore disposal of water, which would also lend itself to our land-based disposal systems. And that's me. I don't think I've ever spoken for this short a time and got to invitation. So thank you for the format, and appreciate everybody's time, and very anxious to speak to anybody through the breakout session or contacting me by email. Thanks again for your time.
Great, thank you, Joe. It looks like there are a couple of questions for you in the chat. I might just ask that you answer those in the chat if you can, just so everyone can see the response, but we will move on just in the interest of time. But thank you for those questions, and we'll move to our next speaker. So last but definitely not least, we have Inflow, and I'd like to welcome Patrick Tuddy. He's the VP of Business Development and North American Operations for Inflow, and we'll give it over to you.
Great, thanks so much, Steve. You can advance to the next slide. So Inflow Technology is a little bit about us. We build innovative water cut and multi-phase measurement systems using well-known, well-understood measurement technologies. We just package them slightly differently using composite materials. You can go to the next slide, please. I'd like to thank Joe, our previous presenter, for bringing up those pictures of coated probes, because that certainly helps with my business case here. We use a patented carbon fiber composite pipe at the heart of all of our meters. So this is a non-metallic, corrosion resistant, sour service standard piece of pipe, which allows us to embed all of our measurement sensors into the walls of the pipe. So that means that we don't have any sensors in line in the pipe flow. We have no contact with the fluids, results in a device that has no pressure drop or obstructions in the flow line, which then means we have no damaging or fouling of the sensors getting coated with oils and other nasty stuff that's in the flow line. So that helps us create a device that has no maintenance requirements and no recalibrations whatsoever. If you can go to the next slide. So we use microwaves to measure water cut, and the reason for this is microwave technology is very accurate. It's well understood and well documented. Because we have large differences between the permittivity response in both oil and water, it allows us to really easily discriminate between the fluids in the pipe. As a lot of us know, the electrical properties of the different flow conditions result in the need for different technologies to measure in both low water cut and high water cut situations. So we've developed two different types of sensors to manage this operating envelope. Both of these use modern digital electronics for optimal stability, and both of these sensors benefit from the fact that we can put them in the walls of the carbon fiber pipe, so there's no contact with the fluids. If you can go to the next slide, please. So we have two different devices. We've got our SureCut low water cut analyzer. So this is a microwave resonator device, measures from 0 to the inversion point in a very high accuracy device as well. And we've got our high water cut analyzer that uses a microwave waveguide. Now this device will measure from the inversion point to 100% water cut with a reasonable accuracy of plus or minus 1% on water cut. We can extend that down below the inversion point, but the accuracy starts to slide a little bit, so it's used more for a trending device in those type of regimes. These two can be combined together as well to give us a full 0 to 100% water cut response as well. You can go to the next slide. So our SureCut, our resonator. Next slide, please. So like I said, this device uses a microwave resonator with a simple antenna, which is actually built into the wall of the pipe there outside of the process fluid. So we can develop a resonator within the carbon fiber composite. We input the energy into that resonator, creating a microwave field within that resonator, and allows us to get a really accurate response at certain frequencies back, which we can then relate to a water cut. If we can go to the next slide, please. One of the really cool aspects of this is by setting those sensors back out in the walls of the pipe is we get a full pipe measurement. So we're measuring the entirety of that resonator cavity within the, or resonator box within the meter itself. So it allows us to get a very accurate, repeatable measurement out of the device time and time again. Again, with no sensors in the flow lines, there's no maintenance or recalibration. We can take in temperature and density measurements from an outside source, such as a Coriolis or a densitometer, which again allows us to increase our accuracy of the measurement, and allows us to run multiple different types of oils and densities of oils through one device at one time. All of our interfaces are fully digital, so we can incorporate or integrate easily into Scada systems using Modbus. We've also got a graphical user interface for setup and configuration that can be accessed either locally with an Ethernet cable or through a Wi-Fi connection, so that the technician can actually go up on a phone or laptop and connect using our full graphical user interface as well. Go to the next slide, please. So our high water cut analyzer. Go to the next one. This device uses a microwave waveguide, which is sits along the edge of the pipe, where we basically have an input port and an output port, and we send energy down the side of the pipe in that waveguide, which is essentially a box with conducting walls. If we can go to the next slide. So in an ideal waveguide, if we had a pipe full of really nice saline water, we would get all of that energy returning from the input port to the output port. But when we do introduce little bits of oil into that flow, we ended up with energy losses into the pipe, and we can relate that back to a defined water cut within that flow line. Go to the next slide. So I just got a couple of quick use cases here. I know we're trying to cover a lot of information in a short period of time here, so I'm going fairly quickly. But we installed one of our SureCut meters down at a truck terminal down in Tabor, Alberta, in January of 2020. It's been running continuously since then, so almost 2 years, with no maintenance and no recalibration throughout that time. We're measuring a lot of different types of oils coming into this terminal. Water cuts from 0 to 35%, densities from 800 to 950 kg per meter cube, all through one device. We were being compared to an existing 2-meter setup where they had a probe measuring from 0 to 5%, and then another full water cut meter measuring from 5 to 40, which is a fairly standard setup for these types of terminals. We were able to show much better response in comparison to the physical sampling. So our average difference was 0.12% as compared to their existing setup at 1.23. So they're paying for a lot of water in this particular terminal. If we can go to the next slide. This was a field application of our high water cut analyzer used at a cold heavy oil well pad, which is on water flood around Lloyd. So client was fairly convinced they had about a 95% water cut emulsion continuously. What they didn't realize is they were getting extremely regular oil slugs of about 27% water cut coming through. The data on the screen is actually just 2 hours of water cut data, so we see the really highly detailed information coming back. And this was proved against a full tank profile and shown to be within 1.5% water cut. And this ran for 6 months with zero maintenance or intervention as well. My next and final slide. So where we want to go next, really what we're looking for is to expand our heavy oil and oil sands applications. These analyzers are extremely well suited to heavy oil applications because of the lack of probes or pipe intrusions. There's nothing to get stuck to on the inside of these meters. So very, very good for passing solids, asphaltenes, waxes, all the nasty stuff through there. Our current calibration temperature limit is 110 C, but we know the device can handle much higher temperatures than that. So we're looking for an oil sands pilot project where we are in steam recovered bitumen type of flows, so we can really expand that operational envelope and help those oil sands operators get better water cut measurement. And that is what we're looking for today. So thank you for your time. Look forward to questions in the breakout rooms.
Great, thanks, Patrick. Very efficient presentation, so appreciate that. We don't have any questions for right now, but I think we'll pass things over to Adele to close, and then we'll head into the breakout sessions. So again, do encourage everyone to stick around for those. But Adele, over to you.
Great, thank you, Steve. So thanks everyone for taking the time out of your busy days to join us. We really hope you learned a lot. I know I sure did. Like we mentioned earlier, the webinar recording will be available through the CRIN website. And don't forget to sign up as a CRIN member if you aren't already. There's no cost to join, and there's a wealth of resources at your fingertips, such as a monthly newsletter, as well as access to challenges and information about our theme, as well as other themes. And be sure to check out our LinkedIn group. You can search for CRIN Water Technology Development, and you can reach out to us directly as well. So you can look for me, Steve, as well as Nick McGregor from Suncor, who is my co-chair on this water theme. We'd be happy to connect you. And if you're passionate about getting more involved, please send us a note, and we'd love to bring you on board. And now you're welcome to network. We'll take the next 30 minutes or so. You're going to be able to hop between breakout rooms. Feel free to go in there, chat freely as you would in real life, and no one is there to facilitate. So yeah, just have fun, ask the questions that are on your mind, and also feel free to connect with folks afterwards. This is just an introduction, and we hope it sparks a lot of ideas. So please look for the survey after this event. We look forward to your feedback and suggestions, and have a great rest of your day. Thank you so much, everyone.